So a very common question that you're going to see in organic chemistry is about boiling point. And they'll say like, take these molecules and go from lowest to highest boiling point or highest to lowest boiling point, or what is the highest out of all these molecules. And so I wanted to make a video because I had some students concerned and they were asking me like, how am I supposed to know that? Like, I don't even have the temperature. And so follow these rules. This should definitely help you. These are my pro tips. So the first thing that you need to know is that the higher the surface area, the higher the boiling point. So don't be one of those students that's just like, oh, this is the longest chain, so this is highest. When you're comparing in terms of alkanes, yes. Why? Because again, if you're going to have a longer chain, you're going to have a higher surface area. If you have a higher surface area, you're going to be able to have more IMFs or intermolecular forces. And then again, that's going to lead to a higher boiling point. So just to prove to you again, propane is around negative 44 Fahrenheit, butane 30 Fahrenheit, pentane 97 Fahrenheit, and heptane around 209 Fahrenheit. So when comparing alkanes, yes, the longer chain is going to have higher surface area and a higher BP. Now, notice in this next example that both of them have 4 carbons, but one has branching and one doesn't. So again, isobutane has branching, and if you have branching, you're going to be decreasing the surface area. And what did we say when we talked about surface area? We said that the higher the surface area, the higher the boiling point. So if I'm decreasing the surface area through branching, then I'm decreasing the boiling point. So that's why branching decreases the boiling point. And just to prove to you about the whole branching thing, again, butane is around 30 F and isobutane is around 11 Fahrenheit. So it just goes to show you that yes, branching is going to definitely decrease the boiling point. Now, I gave you a sneak peek from highest to lowest. So if you have hydrogen bonding, that is going to be a really high boiling point. If you have a dipole-dipole, again, that's going to be a little higher than LDFs, but it's not going to be higher than hydrogen bonding. And then if you have London dispersion forces, that's going to be the lowest. Sometimes you hear van der Waals. Again, that's the lowest. Now, I want to make something extremely clear. For hydrogen bonding, it doesn't only have to be OH. Sometimes students think that, and honestly, it is very common to see OH, but it's not the only way you can have hydrogen bonding. Remember the acronym PHON, F-O-N. So it's going to be F for fluorine, O for oxygen, N for nitrogen. So if you have a bond between F and H, NH, OH, again, those are going to be hydrogen bonds. Now, notice here that I have butanol, I have diethyl ether, and I have butane. Again, if you're not familiarized, the first one you have your OH, so definitely you can have hydrogen bonding. The next one I have the oxygen in the center. And again, you're not going to have hydrogen bonding. If I put 2 of the same molecule, that's what I'm trying to compare. If I take 2 butanols, or 2 of the first molecule being this molecule, if I take 2 and put them against each other, you will have hydrogen bonding. If I take 2 of these and put them against each other, you're not going to have hydrogen bonding, but yes, you could have dipole interactions. And then if I put 2 of these against each other, again, you're going to have LDFs, but you're not going to have dipole-dipole, and you're not going to have hydrogen bonding. So with that being said, here are the temperatures that you're going to see. Again, with butanol, you're going to have around 244 Fahrenheit. Diethyl ether, you're going to have around 94 Fahrenheit, and butane, you're going to have around 30 Fahrenheit. Now, one last comment. Sometimes on exams, they're going to say, I want you to give me the vapor pressure. Pro tip, do it in terms of boiling point first. And then you're going to thank me. Why? Well, because boiling point and vapor pressure are opposite. So if you have a high boiling point, you have a low vapor pressure. If you have a high vapor pressure, you have a low boiling point. So if they're asking you in the question, give me the one with the highest vapor pressure, you need to give the one with the lowest boiling point. Again, they're opposite. So again, if one's high, the other one's low. So do it in terms of boiling point first, and then know that the vapor pressure is the opposite. So if you're having the one with the highest boiling point, that's going to be the lowest vapor pressure. Again, if you enjoyed this content, it takes time to create these videos, so please follow, like, share, and thanks again for watching.